Example 3 in 8.2 for Math 30-1 wants us to go from a original graph to a transform graph. And when they give you a question like this, they will give you, typically a dot or a point on each of those curves. And really all I mean by that is they've pretty clearly indicated that 4, 1 is on our original. I'll put that over here. Y is equal to log base 4 of x. And then what I'm going to do to just try to make this as general as possible is I'm going to apply all my transformations. So I equals A times log base 4, the base doesn't change, of b times x minus h plus k. And then we're going to try to determine what, a, b, h, and k are. So 4, 1 is on the original curve, which means, or I shouldn't say which means, we're going to look at what that became. Now, there are certainly two different ways of doing this. You could do a vertical stretch or you could do a horizontal stretch. And we talked about in chapter 1 that most functions, almost all functions, have a different way of representing both of those concepts depending on what's being done to the function itself. We are not going to push that so much. They give us these points so that we can see that 4, 1, the original, could be treated as a horizontal stretch to go to 1, 1 on my new function. Now, before I do anything else, why can't that be a horizontal translation? And I really would encourage you to, pause the video after I say this, I suppose, and think about it. Why can't I just move the graph 3 units to the left? And, the easiest, I think, point is to look at what happened to 1, 0 on y equals log base 4 of x. If this is a horizontal translation, then what should have happened is that this curve, the entire curve, got picked up and moved 3 units to the left. Now, there's a bit of a problem. We can pretty clearly see that the black curve that I moved is not the red curve represented. The easiest way by far of telling that there is no horizontal translation being done here is that they have the same vertical asymptote. The vertical asymptote of the red graph is still at x equals 0. Now, really what that tells me is that h is equal to 0. And I'm going to put no vertical, oops, I put horizontal there, no vertical asymptote change. The only way we change our vertical asymptote of a logarithmic graph is by, horizontally translating left or right. All right, the other pretty important piece of information here is that it looks to me like that is really the only change that's being done. Now, I want to talk about this, that you could likely do this with other, or you can do this with other transformations as well, but the way that they presented the information, we are going to look, okay, how do I go to 4 to 1? From 4 to 1, I horizontally stretch by 1/4. If I have a horizontal stretch by 1/4, then my b parameter is the reciprocal of the stretch. So the reciprocal of 1/4 is 4. Now, what that allows me to say is that b is equal to 4. I'm not going to do a vertical stretch, so my a value is 1, not 0. I'm not going to do a vertical translation, so my k value is 0, and we talked about how we're not doing a horizontal translation as well, so h is equal to 0. Now, I'm going to put all those in, and what it looks like is y is equal to 1 times the log base 4 of 4 times x minus 0 plus 0. Now, most of that is trivial, right? Adding 0, subtracting 0, or multiplying by 1 doesn't do anything, but that difference in the inside makes a heck of a difference. And we get y equals log base 4 of 4x. Now, we are actually going to talk about a little bit later in this course that there is another way of going from that blue line to the red line, and I'm going to talk about exactly how we could do it in 8.3, but you could also vertically translate that blue graph 1 unit up, and you would get the red desired function. And we'll talk about why a horizontal stretch by 1/4 is the same thing as a vertical translation 1 up when it comes to this logarithmic function. We'll get into that in 8.3, and that'll be just around the corner. There's one example left, and it's a nice application question of logarithms themselves.